Hello, and welcome to this online lecture as part of CYFEST13. My name is Bettina Forget. I am one of the artists exhibiting at CYFEST, and the curators have kindly invited me to speak about my work. I'm presenting a piece called Exoplanet Zoo, and I would like to tell you how that project came to be, my thoughts behind it, and a little bit about myself. I'm actually currently located in Montreal, Canada, and I am an artist, an educator, and I also am the director of the SETI Institute's Artist in Residence program. But today, I wear many hats. Today, I'm just going to focus on my creative practice and the Exoplanet Zoo project. So I'm going to start sharing my screen because it's much more interesting to listen to an artist when there's actual artwork to look at. Okay, so this is my project, Exoplanet Zoo. Exoplanets are planets that orbit stars other than our own sun. And I looked at different ways of describing and classifying them. So why am I starting a lecture or presentation about exoplanets with an old sepia-colored photo? Well, this is a bit about me. This is actually a picture of my great-grandfather, who was an artist. I come from a family of artists. We have artists in every generation. And out of the three gentlemen there, he's the man in profile. And what you see in front of him is his master piece that he drew to graduate from his class. This is a portrait of my great-grandmother at that time, his fiance. So where many artists that I know professionally and as friends tell me stories about how they struggled to convince their parents to let them study art, it was very easy for me because that was what was expected of me. I had a different kind of challenge because while I did go to art school as mandated by my family, I also have a very strong interest in the sciences, especially astronomy. I'm an amateur astronomer. I have a whole bunch of telescopes. I'm very interested in amateur astronomy as part of outreach. I'm a member of and was president of the Royal Astronomical Society of Canada's Montreal Center. So really art and science for me overlap in many ways. I kind of at first lived a double life, but now I found a way to combine the two because I make art about astronomy. And one of my favorite ways of doing that is to do art residencies. And I was very fortunate to be invited to a 6-month residency at the Mont-Mégantic Observatory. Mont-Mégantic is located in Quebec, Canada. It's way out in a beautiful forest in a national park, very, very, very dark skies. It's close to the border to the US, so there's just no light pollution. The observatory sits on a, well, mountain may be too big a word, but it's 1,000 meters up. So the viewing conditions are excellent. And Mont-Mégantic is associated with Université de Montréal, so one of the 4 major research universities in Montreal, Canada. And the researchers that are most active at Mont-Mégantic are exoplanet researchers. So the IREX, the Institute for Research on Exoplanets, uses the observatory a lot to look for data for planets that orbit stars outside of our, well, not in our solar system. So when I was developing my project for this residency, I thought, well, I'm going to look at the kind of work that they're doing. I researched on the IREX website. So what are the challenges? What is their research focus so that I can dovetail my creative practice with what's going on at the Institute? And I came across this really interesting quote by one of the researchers. They said the definition of an exoplanet may be far from unanimous, but the astronomical community does, however, agree on something. the impossibility of classifying these celestial bodies. Now, why is this such an issue? Whereas in the 1990s, we had no idea, well, we had an idea that there may be planets around other stars, but we had no confirmation of it. Between then and now, we have discovered over, or rather confirmed, over 4,000 exoplanets. So right now, the consensus is that if you see a star, consider that there's at least one planet orbiting it. So there's a myriad of worlds out there floating above our heads. The Earth is, or our solar system is by no means unique. And in this illustration, I think this gives you a bit of a hint of what is out there. The way we are detecting exoplanets, it's several ways, and you can sort of pick that up in this illustration, because sometimes a planet will pass in front of the star. So it'll eclipse the star, and we can actually see that with instruments. And so it's very rare. You have to be in the right line of sight to be able to see a planet transit, but you can detect the dimming. And just based on that, we found thousands of stars. There's also a way of detecting exoplanets through a gravitational tug. So as the planet is orbiting the star, it'll sort of displace the star just a little bit, so we know that something is there. That works especially well with very large planets. And we can detect now exoplanets with infrared and even some direct imaging. So there's 4 excellent ways to track down exoplanets. The more we look, the more we find. And what fascinates me about exoplanets is how crazy they are. There's so many different types. So we've got what is called the hot Jupiter. Those were found first because they're so massive and they're like our own planet Jupiter. They're gas giants, but they're orbiting very close to their host star, so they get very hot. But we're also finding worlds that are basically covered in lava, worlds that are covered in oceans, worlds that are covered in oceans that are frozen over, like these ice planets. I find this eyeball planet really fascinating. I read an article about a proposed ocean world that is frozen over, but because it's tidally locked. So that means that only one side of the planet is facing the star. There may be a chance that a bit of that icy crust actually is melting. So there would be liquid water just where it faces the star. And so it would look like an eyeball. I think that is would be very interesting planet to live on. They're even more exotic and extreme, unimaginable world, like this burning ice planet. This is a planet that is also covered in ice, but its atmosphere is so dense and the gravitational pull is so high that the ice doesn't melt, even though it is actually on fire. It's the crazy chemistry that goes on there. That would be a very dangerous world to live on, though not as quite as dangerous as the raining glass world. This is a planet that is also like a hot Jupiter. Even though it is hot, it is beautiful, or that's what scientists discovered, that it is very blue because of something called Rayleigh scattering. This is what turns the atmosphere on our own planet blue, because the way that light refracts in this very dense atmosphere. But because it is so large and so gaseous and so dense and so hot, it actually rains liquid glass there horizontally because it's so windy. You wouldn't last a minute on that world. That is a very harsh environment. What I found also very amusing is a very much of a contrast to that world, a fluffy planet. That sounds much more inviting. Why is this planet called fluffy? Well, its density is so low, it is like styrofoam. So there, I guess you would land and just sink right in. On the other end of the scale, to the very fluffy planet, they're actually diamond planets. So if you thought your jewelry was rare, think again. Diamond planets are actually ubiquitous, and that is tied to the fact that carbon is also a ubiquitous element in the universe. It's very easy to make carbon. So if you have a planet that consists of a lot of carbon, and you place it in an orbit that is very close to a star, so there's a lot of gravitational pressure, that carbon will turn to diamond. So if you dig down a little bit, you can make many beautiful jewels. It's actually hypothesized that even on our own planet, if we dig down low enough, there may be a whole layer of diamond. It's just that we can't get to it. I'm not sure about this illustration actually of this planet, because on the outside it looks kind of shiny and white. It is probably covered in black. It would be like a sooty black, charcoaly kind of planet. But when you dig down, you will hit that diamond layer. And if you thought that the definition of a planet is a celestial body that orbits a star, you may also be wrong. There are things that are called rogue planets. They don't orbit any star. What scientists think is that these planets initially formed around a star, but because they started getting caught up in a gravitational pull with its sibling planets, that they got ejected out of their orbits and are now floating very lonely around the universe all by themselves. So there is a phenomenal amount of different kind of beautiful, exotic, intriguing worlds out there. And that really interested me. I did, as part of my residency, of course, some research. If you are interested in exoplanets, if this sort of crazy menagerie of worlds has piqued your interest, I can suggest a couple of books. I really enjoyed Planet Factory by Elizabeth Tasker. She does a fantastic job of picking a few planets and really looking at, okay, if that planet were a little further out in its orbit, how would it change? And how do we get to have styrofoam planets or Methuselah planets? How old are those planets? How are they formed? The Exoplanet World book by Summers and Treffel is also really excellent. It's a little bit more scientific, and a little more philosophical is Caleb Sharf's The Copernicus Complex. He ponders the question how rare a planet is that you can actually live on. So how rare is life on other planets, not just looking at the planets themselves. Though exoplanet researchers, of course, are all hoping to find a planet that resembles Earth, like an Earth sibling. And so that would be another really interesting way of discovering life beyond our own planet. That's kind of the holy grail, I think, that most exoplanet researchers are going for, and that is certainly helping them to get grants. It's an intriguing philosophical question. As part of my residency, of course, I went to a lot of conferences. So IREX is very, very active. They had a lot of conferences, exoplanet cafes that they do, and get scientists from different universities and research groups together to talk to each other about all that amazing amount of data coming in. And I really enjoyed this graphic, how two types of small planets could form. And it looks like a recipe: just add more rock, have a young planet, add more gas, add more heat, and you get like a mini Neptune or super Earths. And as I was listening to the researchers, there's something that I noticed, and that is the language of how exoplanets are described. So here you'll notice mini Neptunes, super Earths. And in this graphic, it's even more apparent that we are classifying exoplanets based on what we know of our own solar system. So there are super Earths, there are hot Neptunes, cold Neptunes, hot Jupiters, cold Jupiters, super Venus, Mercury types. And that is, it's a natural thing to do, but considering how exotic and diverse the exoplanet population is, it's not really the best way to go about it. And one of the reasons I'm asking, what researchers are discovering, that most of the planets that are being discovered actually have no equivalent to planets that exist in our solar system. They sit somewhere between like super Earths and sub-Neptunes. And that creates a problem. So how are we going to make sense of all the planets that we are discovering? So I was wondering what role art could play in this conundrum, and whether the exoplanets themselves could determine their own taxonomy rather than us imposing names on them. Could the makeup and the data generated by the exoplanet research give some sort of indication of how we could categorize different kinds of exoplanets to facilitate our research? And so this is what I came up with. I started with a sphere in a 3D modeling program, and I said that this is my protoplanet, and now let's do something with it. I had previously worked on another 3D project where I basically looked at the code of an STL file. So for all of you who do 3D printing, you will know this. STL is the most common file format for 3D modeling, especially if you want to 3D print something. And normally you would save an STL file in a binary mode, and then you go and print it. I was interested in seeing the actual code. So if you open a binary file in just a text document, you'll get some sort of crazy word salad. It'll all be letters and symbols, and it'll make no sense. But if you use a 3D modeling program like, say, Rhino, and you click what I circled there, the ASCII option, you get this beautiful code. And I love code because as an artist, I like to mess with things. And I decided to mess with the code. All these numbers reminded me of a whole bunch of other numbers I saw about exoplanets. So this is from an exoplanet catalog. These are data that are freely available online. I think you get, I got through it through the NASA website, but I think you can also get it through IREX and ESA. And there are some basic parameters that I found the most interesting, because based on the lectures that I saw from IREX, like what is the recipe to make different kinds of planets? Well, what's most important is the mass. It's how far the planet is from its host star. What is the shape of the orbit? So is it really eccentric? Is it really close? And of course, the stellar properties. So what kind of star are we orbiting? Is it a really hot blue star? Is it like this slow burning red dwarf? So that also makes a difference. So I took all these data and I plugged them into the STL file ASCII code. And you'll see here, some of these numbers are underlined and you'll see them repeating. So I put in planet mass, the semi-major axis that pertains to the planet's orbit, and the orbital period. So how fast is that planet orbiting the stars? And then I crossed my fingers and I said, well, what will that look like? And it gave me an actual visualization. So what it does when you mess with that code is that it takes coordinates from these vertices and it just places them elsewhere in space. So I thought that was an interesting start. I did some digital manipulation with it. I did some digital editing here, and here you can see which stars I messed with. And I thought it would be interesting if the different spikes and the different shapes could then give us indications of what kind of star that is, so that you could read exoplanet taxonomy just by looking at it and looking at this data visualization. And so I plugged in lots of different data sets at different places in the code, and then brought them into my digital software image editing software. I liked the kind of aesthetic of it. It reminds me of a blueprint. It's like an architect's vision of an exoplanet. These are, of course, now all three-dimensional shapes that cannot exist because the vertices are glitched. So you cannot actually print this. And I was very interested in having these as objects. But with a bit of manipulation in Rhino, I managed to close and repeat some of the code, and I printed these up. Now, this is part of a art residency for 6 months, so I would have liked to print more, but this was a fairly experimental little thing that I was doing. So in the end, I printed up 9 of them. It's a play of how many planets we have in our own solar system, which is 8 plus Pluto, which doesn't really count as a planet, but I decided to do 9. And then once I had them all printed up, I thought, how can I contextualize them? And that's why I got the idea of putting them into glass domes, like these bell jars, and put them in basically a cabinet of curiosities, a Wunderkammer. Because firstly, I think that all these kind of different crazy planets that do exist in our universe, it is a cabinet of curiosities at a cosmic scale. But I also like this play on the kind of science that we're doing now and that we used to do when collecting and classifying was the major way we did science. And that's when it was still called natural history. It here a couple of shots actually of the installation, and you'll see in front, we had these big work table, and you'll see a couple of the 2D printouts there. And I also put in all the information about the codes because I wanted the visitors to understand how I constructed this project. So this is my inspiration, the classic Wunderkammer, and that idea of collecting curiosities from around the world. And this kind of very Western perspective on collecting as well, that anything that was not from our own home was exotic. Though it's not exotic if you're actually in Papua New Guinea, then that's normal for you, and everything in Great Britain would be exotic for you. But are we not doing the same thing when we're just using our solar system as what is normal and then everything else is exotic? Maybe for somebody living on a fiery ice planet, our Earth would be exotic. And I'm also was thinking of this kind of colonial perspective on collecting specimen. People like Humboldt and Darwin who would go on boats and just collect animals from all over the world and bring it back and just try to make sense of where does it fit in the larger picture of all life. So in a way, what we're doing with Exoplanet is just like a larger cosmic version of what we used to do here on Earth when we discovered new continents and new life elsewhere on our own planet. And there is there's a philosophical implication there. Linnaeus started the idea of systemizing classifications and creating taxonomies so we could better understand the world around us. And that sort of created a way of thinking around the world, especially in Victorian times, that was really hierarchical, with sort of lower life forms at the bottom and, not surprisingly, man at the top. And it's seen like a tree, and it's very directional, it's linear, and there's some sort of sense of achievement of making it to the top. But it's a really anthropocentric view of nature, and one I feel that is flawed. I love this doodle in Charles Darwin's notebook, because it gets criticized because he basically conceives evolution also as a tree. So you start at the bottom with one, and then the tree kind of fans out. But it does sort of foreshadow, especially if I look at it just from an aesthetic point of view, it does foreshadow a current thinking about science that is more network-based. So if you look at the graphic on the right-hand side, it's from a more recent paper about the evolution of bacteria, and it echoes Darwin's drawing. But what I find fascinating is that today we realize that there's a lot more sort of cross-fertilization, and that we are much more of a distributed horizontal network, more of a rhizome than a pyramid or vertical tree of life. That we live in a complex dynamic system that is always changing, and evolution is not static. So I think we need to take this kind of thinking and apply it to exoplanet research as well, which is why I kind of stumbled over this graphic where everything is sort of based on our solar system. And I wonder if these frames of thinking may hamper research and scientific research. And I think it's the job of artists, and especially artists in residence, who are invited into scientific institutions to ask those questions. This is what the humanities do. This is what we can bring to the party. And this is why I thought having the planets themselves suggest their own taxonomies would be a non-hierarchical and much more interesting way of going about it. Now, the variance of the different shapes, you can see some that are very varied, others less so. I think this was like a first draft, and I would like to maybe print these a lot larger so that the variances show more. I also made some decisions on color. So obviously hot Jupiters were red and water worlds are blue and ice worlds are white. So there's a bit of a color coding also that I imposed there as well. So some aesthetic choice from the artist. Because these, the graphics and the original 3D model shapes that are created are basically impossible. And I had to do a lot of work going in and closing all the shapes up so they could be 3D printed. I thought, wouldn't it be interesting, rather than bringing these planets, these glitched planets, into our world, couldn't we just bring the scientists into the digital world? So I did another residency at Xenoform Labs that is run out of San Francisco and focuses a lot on new media and technology. And I got a chance to work a little bit with virtual reality there. And this was a collaboration with Scott Kildall, who also runs the Xenoform Labs and is a media artist himself. And he gave me an intro to VR and programming, and I borrowed some of the skins, very colorful skins that I dressed my exoplanets in. And here's an action shot of the vernissage where I had people just float around in and through my exoplanets, and a couple of screen grabs of, so this is Kepler 34b, that people could fly through and on and explore them a little bit more close up. So that was a phenomenal experience. And I'm very much enjoying VR as well. And also staying in the digital realm. So this is a new thing. I've also launched an NFT. So this is Scott Kildall has also just done an NFT as a performance piece. I think it's interesting for artists also to question what that digital world is and how it works. But I jumped in, and this was in collaboration with a friend of mine, Nick Edgar, who's a very talented computer programmer who put this online for me. So as I've been talking, I think you'll have noticed how important it is for me to work with others. Of course, I have my own interest in astronomy and science in general and philosophy, but to exchange ideas with people who work in that field, this is really where my inspiration comes from. And doing residencies at scientific institutions, I think, has benefit not just for the artist, but also for the researchers there. So I remember when I did my exhibition after the Mont-Mégantic residency, the researchers came and saw the artworks and were really delighted because they get to see their own their own scientific work through a different lens. And I know this, how well that works from the perspective of an artist, but as the director of the SETI Institute's Artist in Residence program, I also know how well it works for an institution. So I just want to end by talking a little bit about the SETI Institute's Artist in Residence program. So if for those who don't know the SETI Institute, our mission is to lead humanity's quest to understand the origins and prevalence of life and intelligence in the universe. So that means we are looking for life beyond Earth. So either with the Allen Telescope Array that you see here, that is situated in Northern California near Hat Creek, but also at the Institute, there's a lot of exoplanet research and astrobiology research that looks at how life began. And so we run an artist in residence program, and what basically my job is to connect contemporary artists, so mid-career artists who have an interest in art and science with our researchers. And there's a dialogue that happens. So typically I will match an incoming artist who already has an interest maybe in astrobiology, microbiology, data processing, language, communication, acoustics, and then match them to a researcher who works in that field. And the curatorial direction of a program is really sort of considering what is intelligence, both here on Earth and possibly beyond. How did life begin? Which also implies another question, that is, what is actually life? There is no official definition of what life is. We know what a human life is, but life in general, how that is defined, there are a lot of different approaches to that. And there's also a thought that maybe we're looking too much toward biological life, that non-biological actors could also have consciousness. So this is where science and philosophy really overlap, and that is really fascinating field. And also I like for the AIR program just to look at our anthropocentric worldview, and because it's very easy to slip into that, and artists can sort of kick the tires and just ask, like, is this the best approach? And sort of, that critical reflection is something that current artistic practice is really strong in. It's a very international program, so we have artists from all over the world, and I think that is important because if you want to have a diversity of views and critical views, it's important to have diverse voices. That also means that we're not just doing visual arts, but we have had choreographers and dancers. We have currently a spoken word artist, 3 artists that work in music and sound, of course, installation arts. So it's a really fascinating group. And we have institutional partners. So the Multavo Art Center will sometimes host our artists actually at their physical residency. We have an archive at the Center for Art and Environment at the Nevada Museum of Art. So all of our artists do have archive sets that researchers can look at the museum. And we're also collaborating with the Long Now Foundation. And we were very delighted this year to collaborate with Ars Electronica with the SETI and AI residency that was run by Interspecifics, who did a phenomenal job. And also we organize projects with smaller institutions such as the Brooklyn-based theater Me Too, who did a wonderful piece about the future and how we imagine the future. If you would like to find out more about our program, I think the best thing for you is to check out our website. So we have our current artists and our alumni there. The program is invitation only. I think I should mention that now. We do not have right now a way for you to submit portfolios. We have a group of advisors who suggest and nominate artists for consideration, because we're a really small program right now. This may change. I'm hoping that we'll have a nomination process that is open to the public soon. But you can still get in touch with me if you have any project ideas or ideas for collaborations. I'm always ears, always happy to meet new people and to collaborate on interesting projects. So that is it. That's all about my project. Thank you very much for your time with me, and thank you for everyone at CYFEST13 for inviting me and including me in this wonderful festival. If you want to follow me or get in touch with me, you can follow me on social media, and I also have a website. So thank you very much for your attention, and have a wonderful time at CYFEST if you can attend in person.